So the topic, C.2, exists function. Yeah. So from the name, you can guess this function, how do we use this function? This function is very simple. Yeah. The definition of this function is very simple, yeah. But it could be used in some relatively hard queries. The harder part is mainly in the logic part. The logic part. Yeah. Yeah. So let's see this function definition first. All right. Exists function in SQL. Yeah. Check whether the result of a correlated nested query. Yeah. Mainly we use it on the inner query, not outer query. So outer query, we do not use this function. Yeah. But the inner query, we expect it returns some query result, right? So it should be a multiset. Multiset, certain number of rows. Yeah. But there is a possibility the table is empty, right? Yeah. When we do query, the table is empty. So we want to check if the return table is empty or not. So it exists. Okay? Empty, it does not exist. Okay? The return result does not exist. Return table does not exist. Otherwise, non-empty, yeah. So return table exists. Yeah. Straightforward meaning. Yeah. So this definition, very easy to understand, yeah. But the harder part is the logic we use to write this kind of queries could be hard. Yeah. So when we do our, logic thinking, if you think in this way, yeah, relatively hard. Yeah. So we will see. Yeah. True if the nested query result contains at least one tuple. Non-empty. Yeah. Straightforward. Yeah. False if the nested query result contains no tuples. Yeah. So that's simple. Yeah. Later we will see a negation version of this one. Because this function, if we add not exists. Yeah. Not unique. Yeah. We have many functions. Okay, not. We just add a not in front of this function name. Exists. So then we just negate, right? Yeah. The reason sometimes we want to use the negation version because when we use our logic thinking, we feel better. Yeah. Because sometimes we feel comfortable thinking in this way. Sometimes we feel comfortable thinking in that way, right? Yeah. Sometimes normal way, sometimes negation way. Yeah. It's very common. Yeah. Very common. Yeah. Although some people may argue, these two versions function equivalent, right? Yeah. Equivalent. Yeah. But when you do understanding, usually one version is easier than the other version, although both equivalent. Yeah. That's true. Yeah. Equivalent. Yeah. That means if you can use the exists function to write a query, you can also use not exists function to write, an equivalent query. Yeah. But you will see one version is much easier to understand than the other one. Okay? Yeah. So here we have these two versions. We just picked the one that we feel easier to understand. All right. Not exists function. Okay? Just the opposite. Yeah. Definition. Yeah. Just opposite here. Empty, then true. Yeah. Not exists. Nothing. Yeah. False, not empty. Yeah. Negation directly. Yeah. But later you will see. We have. So here at the beginning of the class, I said the hardest query question of this class, we use this not exists. Okay? Actually, you may have the situation sometimes you may need to use double negation, right? Double negation. Yeah. Think about that. Because when we don't understand it, most of the time people do not like the double negations, right? Yeah. But sometimes, in order to represent one specific requirement, you have to use the double negation. That makes the understanding much harder. Yeah. Double negation. Yeah. Yeah. You will see it. Our next slide, you will see it. Yeah. All right, yeah. Exist and not exist are typically used in conjunction with a correlated nested query. Yeah. Yeah. The exists part, yeah. Usually, most of the time, the exists function easier to understand because no negation. No double negation. So the hard part is not exists. That version. Usually very hard to understand. Yeah. Very confusing. Yeah. So this class we will spend a lot of time. So to understand the hardest question of this class, we may need to spend a lot of time try to understand. Yeah. All right, so let's start understand these two functions. The first example, using exists function. Now, this one is pretty simple, very straightforward. Yeah. So this one, just give you idea, actually we just get one of our old examples. Yeah. Old examples, we didn't use this exists function, but we converted to a version using exists function. Okay? Yeah. All right. Look at this query statement. This one, pretty easy. Yeah. Just a simple, table join example. Standard table join, inner join here. Okay? Yeah. We join two tables, employee table, dependent table. Okay. You can see the meaning. The meaning is we want to list those employees' names under the condition. Okay. The condition should be these employees, they have dependent, at least one dependent with the same sex as the employee itself. Yeah. That's the requirement. Okay? Yeah. Same sex. Yeah. So here you can see the let's say same sex. E dot sex equals D dot sex. Select condition. So the join condition, another select condition. First name. Dependent first name is the same as the employee's first name. Okay. Two conditions, two select conditions. Yeah. All right. Then this is the join condition. Okay. Yeah. Yeah. All right. So this one, now we want to use exists function to write it. Yeah. This time, look at this. Okay, yeah. This time we make it correlated nested query. So here you can see outer query, we only have one table, employee table. Then inner query. In the inner query, we apply this exists function on the whole inner query. The whole inner query. Okay? So what's that inner query? Then, because from the outer query, we fix one employee. Remember? How do we understand correlated nested queries? We select one tuple from the outer query. Then we fix it. So one employee in the outer query, we fix it. Okay? That E, we fix it. All right. Then we bring it into the inner query and go through all the tuples in the inner query with and using this fixed tuple from the outer query. Here, that E is fixed, right? From the outer query. E dot F name equals D dot dependent underscore name. All right, yeah. Yeah, so here also, the previous join condition, we use it. Okay, connect. Yeah. All right, so then this one, so we do some inner query under these conditions, and we want this query result not empty. Not empty, exist function returns true, so we select it. So the logic is like this. Yeah. So you can see the thinking way quite different from our old way. Yeah. We cannot say which one is better than the other. So here, okay? Some people may like the first one, some people may like the second one, right? I feel comfortable. Yeah. The first one, straightforward. You can argue the first way, much simpler to understand. The standard table drawing. Yeah. But the second one, do not just say the second one is always worse than the first one, because the second one, this exists function, actually it gives you a special tool for you to write some types of queries. Special tool. Yeah. Yeah. Because sometimes when you need to write query statements, especially relatively hard query statements, so you want to try every possible ways to write. Yeah. Sometimes this way you feel hard, so you change a different way. Here, this exists function, so you have another special view to help you understand your query statement. Yeah. So it's a useful tool, so do not throw it away. Yeah. All right. Right. So here, actually, because it looks like much harder than the first version, yeah. But here we want to say, we want to keep an option. So this is an option for us. Sometimes we may need this option. Yeah. All right. Yeah, so here, but for a multiple requirement specified by select statements, it is useful. Yeah, because sometimes you may want to separate. You may want to separate in two different steps. So nested queries Outer query easy to write. It's always easy to write outer query. Okay? So then you just work on the inner query. So you divide it into two steps. That structure, sometimes it could be easier. Then you consider, two things together, mixed two things together. Yeah. Yeah. All right. Yeah. Then, example using exists and and. Yeah. And. Yeah. Because we may need to combine multiple parts. Okay? Yeah. Exists, you just apply it on one of the inner queries. Think about it. Yeah, so here, there is a situation. When you have outer query, so here, let me draw. Suppose this is outer query, okay? Yeah. Outer query, all right? Then, when you get into the inner query, you have inner 1 and you have inner 2. How about that? Okay? More complicated, right? One outer query covers 2 inner queries. This structure. Yeah. Think about this situation. Now, it will happen. Yeah. But this structure, you can see, if you want to use our previous way, the version, so we use table join directly, then it could be relatively hard. But with this structure, outer query, inner query, the first part, second part, each part we need to use that exists function. But to join them, we use this AND operator to join the two parts. Very natural. You can see, right? You can even extend. You have inner 3. Okay? 1, 2, 3, 4. It's possible, right? So you can see, Then if you go back to our previous slide, you can see this exists function way actually gives you better capability to write query statements, especially relatively hard query statements. All right, so let's look at the new example. List the names of managers who have at least one dependent. Here you can treat, so there are 2 requirements there. So you want to, represent these 2 requirements. The first one, managers. Okay? So outer query, you list the name of those employees. Then you get into the inner query. The first inner query, you want to make sure that employee is a department manager. Okay? That's the first query, okay? Inner query. Then the second inner query, that employee should have at least one dependent. How about that? Okay? Yeah, that's interesting, right? Yeah. So let's look at the split. Yeah. Before we write a statement, we want to split the requirements. Okay? Each requirement, we write one query statement. The first one, employees who have at least one dependent. Okay, yeah. That's easy to write, right? Who have at least one dependent. Okay. Second one, employees who are managers. Okay, yeah. All right, so now after we split it, then we can use correlated nested query to write. So look, using the structure here. Okay? Yeah. That structure here. Okay? Yeah. So let's see. Oh, yeah. So let's see the details here. All right? Yeah. So let me write it shorter. All right. All right. Okay. So outer query always very easy. So you don't worry about outer query, always very easy. F name, comma, L name from employee. Then we move to the inner query, where inner one, okay, we'll put it, inner, one exists function. We apply it on the first requirement. Select star from dependent, where SSN equals ESSN. This query should not be empty. Okay? Yeah. So for the current employee, it has at least one dependent. How about that? Okay? Yeah, exists. And the second requirement. Select star from department where SSN equals MGR underscore SSN. Second, now query. See? Both conditions, both requirements must be satisfied. Parallel, yeah, this way. Okay? How about that? Yeah. Think about, based on our understanding, the logic structure here, if I add a third condition, fourth condition, right? Yeah. It looks pretty complicated. You need to satisfy 4 different requirements, right? Think about it. It looks so hard. How can we write a query statement covering 4 different requirements, right? Yeah. But here, not too hard. Yeah. So you list 4 different requirements separately in parallel, right? Then you use this structure. All right, so that's the one type of complex queries. We learn here. Yeah, all right. Next one, using not exists function. This time negation. Yeah. So the understanding would be harder because we want to negate it. Okay, negate it. Not. Sometimes, here in negation, the reason it's hard, sometimes the original query statement does not have the negation in it. Original query statement, it's the normal description, and no negation inside original query statement. But when we write it, we need to use negation to understand. That's the reason it's hard. How do you know you need to use negation? Way to write it, right? Yeah. After we learn, so we have the experience. Here, we learn here, this class, yeah. So at the end of the semester, near the end of the semester, yeah, I want to at least let you see this type of complex queries. Okay, so yeah. All right, let's look at this query statement. The sentence is not long. See, the sentence is pretty short. Okay, all right. Retrieve the names of employees who have no dependents. Oh, yeah, this is a simple example. Yeah. This simple example. So the first one, we use not exists, straightforward. Understanding is very easy. Yeah. The next one will be harder. Yeah. So this one, very simple. So this time, select that employee, then inner query, this time, yeah, because no dependent. That means if we do the query to get all the dependents from a selected employee, it should be empty, not exists. Yeah, so we write in this version. Okay? Yeah. All right. Think about if we do not use not exists. If you just, use our old way, any way you like to use, but do not use this not exists function, how do you write this one? Many different ways, right? Yeah. No dependence. Remember, you can use count function, right? Count function. Count function, you count, the count number equals 0. Yeah, wherever, if you can find a similar example. Remember, we count number greater, more than 2, more than 1, right? Remember? Yeah. So you just change that condition. You count. Yeah. So your inner query, you count the number of dependent, but equals 0. Yeah. So you can also write in that way. Yeah. No dependent. Yeah. All right. So here, another way. Now this one. This is the one I said it is the hardest example of this class. Hardest to understand. The reason is we need to use negations. We need to use negations. But from the original statement, we cannot see why negation, right? Look at the first example, you can see the negation because no dependent. From this word, no, you can see the sign to use not exists, right? But the second one, you cannot see that. No, not. You can not see that kind of related words. Retrieve the name of each employee who works on all the projects controlled by department number 5. This requirements is very hard to represent. Try to understand this requirement. You will see it is very hard to represent. Auto query, very easy. Employee, its name. Okay, first name and last name. Auto query. So then you're getting to the inner query. But inner query, what's the exact meaning? Because when you understand this sentence, you may have several different ways to understand. For the language understanding, you want to understand the exact meaning of it. So, this employee works on certain number of projects, right? Yeah. You can consider this employee, each employee works on a list of projects in the company. Okay? Yeah. Get that list. Okay? The whole list of the projects that one particular employee who works on it, that list. All right. Then another condition, that list happen to be controlled by Department 5. How about that? That whole list, all of them, the whole list, happen to be controlled by Department 5. Because Department 5, the whole Department 5, they need to work on certain number of projects, right? Yeah, list the number of projects. Another list the number of projects. Department 5. But Department 5, the list controlled by Department 5 contain the list of this employee. How about that? How about that? Okay? if I draw a diagram here, yeah. Because the first thing, we need to understand the exact meaning. After that, then we can, try to use appropriate functions, structure to represent that meaning. Yeah. All right, so here there are two lists, okay? Yeah. So list 1, okay? List 1. Yeah. So that's the project, the project for current employee, okay? Yeah, current employee. Yeah. Then list 2, okay? Yeah. Another list. This list could be larger list, right? Controlled by D5. How about that? Department 5, okay? Yeah, employee D5. Then this list 1 should be a subset of list 2. How about that? A subset. Okay? Yeah. Yeah. All right. Yeah. That's the, language understanding. We understand from the, first from, language part, yeah, understanding. After understanding this way, the next thing is, how do we use the SQL statements to represent this whole requirement together? Okay? Yeah. So you may have different ways to write it. Different ways to write it. Yeah. All right, so here, so here in this class, right here, here we use this, negation way, not exists way, negation way. Yeah. The first time when you see it, you may feel not very natural. You may feel it's not very natural, yeah, but later you will see, actually it's a good way to do it. It is a good way to do it. Okay? So you need to try to get used to it. Try to learn this thinking, this way of thinking. Yeah. So later, if it's possible, so you try to use this way to write some relatively hard queries. Yeah. All right, so here, consider two sets. How about that? List 1 is set 1, right? List. So look at that. So if I draw a diagram, so here, I draw a diagram using circle. Circle. I draw a circle like this. A set and a B set. A set is a subset of B set, right? A set is completely inside B set. That's a subset meaning, right? So A represents list 1. B represents list 2. Yeah, all right. Then, with this picture in our mind now, we represent using SQL expression, SQL operations, and functions to represent this requirement. Okay, yeah. It does in this way. Okay, all right. Because A is completely inside B. Yeah. Then we have a set operation. Here, first we use set operation. The set operation is A, or yeah, I touch it. Yeah. A minus B. You know this operation, right? A minus B. Yeah. minus B. In A, we remove all the elements that belong to B. That's the meaning of this operation. You consider this set, A minus B equals empty, right? This, because all the elements in A must belong to B, so this must be empty set. Okay? Empty set. It's an empty set. How do we represent empty sets? Set not exists. How about that? Not exists. Okay? So we use A minus B, that query result. That query result. This minus, remember, we have an except operator. Except operator. A except B. So we represent A first, then represent B second, except between them. Then the whole thing we're putting not exists function. How about that? Okay? Yeah. So let's look at the query result. Okay? All right. This looks like opposite, right? Yeah, based on our understanding, it should be the other way around, right? Yeah. Let's see. Yeah, not exists. But here, it looks like, yeah. I could be wrong, yeah. So yeah. Let's try our best to understand. Yeah. All right. Yeah, because the one here, it looks like a B first, right? B except A. Yeah. But here, if we, based on this understanding, we know B works on all the, sorry. Yeah, my explanation is a little wrong, okay? Yeah, so here, yeah. My explanation, I need to fix it, yeah. Yeah, this is correct, this is correct. Actually, the other way around, it should be A and a B inside A. Yeah. Why? Yeah, because look at the understanding here. Yeah. So that's why I say this one hardest. It's very confusing. Yeah. All right. Who works on? So this employee works on all the projects controlled by Department 5. Okay. Yeah. So actually, that means list 2 is a subset of list 1. Look at that. List 1 is larger. Okay? List 2 is smaller. And list 2 is a subset of list 1. Why? Because list 2, all projects control Department 5. Okay? That's a whole list, right? Whole list controlled by Department 5. And this employee works on all of them. And this employee could work on more than that, right? This employee, after he or she works on all the projects controlled by the Department, he or she could work on a few more projects, right? A few more other projects, okay? So just the other way around, yeah. That means this employee works on more than Department 5, the whole department. Okay? Yeah. Yeah. That's the original meaning. That's the original meaning. So we need to write it the opposite way. This. B minus A, then this should be empty. Okay? Just to, switch B and A. Yeah, so, yeah. In this way, you can see the difference. These two ways. Which one is larger, which one smaller, which one outside, which one inside. Okay? Yeah. So then, the result not exists, then B except A. So here you can see that's the correct way to write this query statement. Think about that. Yeah. 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 The first time I explained, just direction is wrong. Direction. Yeah, because I feel, one employee should work the number of projects less than the whole department, right? But actually, not necessary. Not necessary. Yeah. It could happen, the whole department, the projects they work, still not as many as one particular employee. Yeah. It's ridiculous or not, that's, we don't question that. Yeah. I mean, we just write the query statement as given. Yeah. All right. Yeah. Yeah. Here, after we see the solution here, another thing, we want to understand why we use this negation way, not exists way. Yeah. So we try to find some rule here. Because you want to apply the similar thinking on other appropriate query statements. So you want to learn this special thinking. Yeah. Here you can see on the what situation, usually we need to use this special thinking. Now, here, one special word can give you a sign. All the projects. Control all the projects. Covering all the projects. Controlled by some departments. That all. Yeah. Because how do you represent all? Right? It's not easy to represent all projects. Okay? Yeah. Yeah. Think about that. Yeah. Yeah. So here, this negation way, so when we try to represent some requirement containing the all meaning, yeah. So it's very likely you can use that negation way to represent it. Yeah. All right. Not exists. All, yeah, because after you remove so one set, but you remove from another set, not exists. That would give you all requirement. Okay, all requirement. Yeah. So this all has some connection with negation. Some connection with negation. In logic. Okay? Yeah. All right. Yeah. So then after we learn this, yeah, so if you can understand, so you can see we spent a lot of time trying to explain this specific one. Yeah. Try our best to understand. Then I will give you practice query question 10. 10, that's 5 plus 5. 5 basic queries plus 5 complex queries. 5 complex queries, I try to give you different types. And this type, I may give you one or two, at the most. Yeah. So probably one should be enough. Yeah. One or two. Yeah. So you can practice. Yeah. Try to use this thinking, logic thinking, to write the query statement. Yeah. All right. Yeah, negation approach. Yeah. All right. Then C.3, negation approach. Yeah. So we try to understand a little better in this. Yeah. Actually, we already, yeah, previous slide, we already. Yeah. So here you can see, yeah, find the tuples that satisfy some requirement. Yeah. Find those tuples such that for each tuple, the result that the requirement is not satisfied is empty. Yeah, so that's the, yeah. So the first line, that's our original objective. Yeah. So we want to do the first line. But to do that, we have this negation way to do. So how to do it? So find those tuples such that for each tuple, the result that the requirement is not satisfied. Yeah, we negate it. Not satisfied is empty. Okay? Then, here it looks like double negation, right? Double negation, because not satisfied, first negation. Empty means does not exist. Second negation, right? Double negation, then you get a, positive thing. Yeah. So here, we use that logic. Yeah. That logic. Yeah. All right. Yeah. So here, you can see who works on, yeah. So that's the same one we did before, right? Yeah. Interpretation. Those were controlled by Department 5, but not worked by the current employee form empty set. Yeah. Those employee worked by Department 5, that's B. Yeah. That's our previous B set. But not worked by the current employee. Yeah. That's except A. Yeah. Not in B, but not in A, right? So we use this way to represent. B backslash A to represent. And this is an empty set. Yep. That's the negation approach. Okay? Yeah. Yeah. Here, this negation, you can generalize it. Yeah. We just have one example, but you can generalize, a little more general situation. I try to create two this kind of negation questions in your next practice assignment. Yeah. Next, for in the complex query part, 5 questions. So 2 of them, but 2 of them should be slightly, the structure-wise, slightly different. Yeah. All right. Understand the negation approach. Those projects controlled by Department 5, but not worked by current employee, form empty set. Yeah. So that's one. Yeah. So set A, yeah, here, set A controlled by Department 5. Just different from what we used before. We used B before. Yeah. Here, A, and B, projects worked on by the current department. Yeah. All right. Then, usually there should be some overlap, right? Usually there should be some overlap. Yeah. And A except B, so that's this part. That's this part. A except B. Okay? you can see if A except B is empty, then A is completely inside B. Yeah. A is completely inside B. Yeah. All right. Yeah, so here, let's understand the query. Yeah, so that's our old solution. This is our old solution here. Now, I modify our old question a little bit. Okay? This time, I want to check your understanding. So if you can, pick up the subtlety of the requirement change. Retrieve name of each employee who works on exactly all the project controlled by Department 5. Here, exactly all, okay? Same, A equals B this time, right? Exactly. So now A equals B. Okay? So it's different from the previous version. The previous version, A is contained in B. Okay? B could be larger. A is inside B. All right. But after I make this change, exactly all, then, B also contained in A, right? A is in B and B is also inside A. Both true, then they are the same. They are the same. Yeah. So when you write the query statement, you need to have two parts. Okay? Yeah. A/B, \B is empty, and B/A is also empty. Okay? Then you get exactly the same. Okay? Yeah. Here you can see. Yeah. We added one word that you need to do in a different way. Yeah. All right. But when you write, you just add, because look at the first part, A is contained in B. Then the second part, B contained in A. So the first part, A is a subset of B. The second part, B is a subset of A. Look at that. Okay? Look at that. Okay? Good. Yeah. So here you can see. So you should really understand exact meaning in the requirement in order to write the query statement correctly. All right? Yeah? All right. Next. All right. Using not exists and in operator. Yeah. Combine these two operators. Yeah. All right. The reason we want to use this way, because there is a very important thing. So MySQL does not support except operator directly. Yes, directly. Yeah. 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 Because it is relatively complicated to implement. So if it does not support, then we have to find a different way to write it, alternative way. So when you see except, if you find doesn't work, then you have to find an alternative way to do the same thing. Here we use, how do we do it? Not exists and in this way. to do the same thing as except operator. Yeah. All right, so look at this one. Retrieve the naming variable works on all project controlled by, yeah, so that's our old one, okay? So our first version. Yeah. Yeah. This one, this time, we write our solution, we try to avoid except operator. Yeah. So we assume we cannot use it. Okay? Yeah. Because some DBMS do not support except operator. So you need to find a different solution, different way to write it. All right. How do we write it? Yeah, this is the the first version using the except. Okay. Yeah. So we want to do the same thing without using except. Yeah. All right. So how to do it? Need to rewrite a part that uses except operator. Yeah. All right. Not exist, still not exist. Okay. Yeah. The function will still apply now. But when we represent inner query, we will use that in operator to do it. In operator. Yeah. We do not use except. But we can use other operators. Yeah, yeah, that's in operator. All right. So here our goal, we want to write this part, rewrite this part. Okay? If we can write this part in our inner query without using except operator, then we get a different solution. Because we can copy the new version of this inner query and put in the not exists function. So we can get around that except operator. All right, so let's look at how do we get around it. Yeah. All right. All right. Yeah. Using not in operator. Okay? Except A except B. Yeah, here. Remember, so our goal, we want to represent A except B. Okay? All right. So now we cannot use except keyword to write this expression. Can we say the project number in set A and the project number not in B? How about that? Or, sorry, A except B. So A except B. Oh, sorry, yeah, sorry. So B is outside. All right, A is here. All right. Or actually, because here we want to write a general case. A here, B here. Okay? We want to remove this part from A. Okay? So here you can see, to write this expression, so actually we want to write these elements. These elements, okay? These elements. This part. So these elements, first, they should be in A. So we can use in operator, in A. Yeah. But these elements not in B. Not in B. Okay? Then that's the same thing as A except B. Okay? All right. Yeah, so here our goal, so this is our objective. Yeah. All right. A except B, so that part we want to represent. Okay? So this part we want to represent. In A, but not in B. Okay? In A, but not in B. All right, yeah. So we need this part. Yeah. Not in B. The project number not in, this is B, okay? This is B. B inner query corresponds to B inner query. So the P number not in B query, but P number should be in A query, A's inner query, but not in B inner query. See? Yeah. Yeah. So you combine two conditions. Yeah. The P number in A query, but not in B query. The whole thing together, you get that, this part. Replace that inner query. Okay? Yeah. Yeah. Yeah, but here, here I didn't write the P number in A query. So you can write it easily, right? Yeah. Because in A query, okay? P number in, you write a select statement that gives you all the project number worked by the current employee, right? Yeah. Not current, by department 5. Okay? Yeah. Yeah. So this one, look at that. How about you just take this one and P number in this one. Okay? Yeah. In that one. Okay? Yeah. Then you do not use except. Yeah. You can do the same thing. Yeah. Equivalent. Yeah. So you fix that problem. So the MySQL does not support this except operator. Okay. Yeah. And this situation could happen. Yeah. Sometimes there are some special operators that one particular DBMS does not support. That's very common. Okay? Very common. Especially when you change from one DBMS to another DBMS. Okay? MySQL to Oracle, or Oracle to MySQL. Yeah. You will have this kind of situation. Sometimes. Sometimes. Then you need to do the same thing without using some specific keywords, operators, yeah. Like we're doing here. Okay? Yeah. So most of the time you can make it. Yeah. It's not easy, but you can make it. Yeah. So definitely you can find a way to solve it. Yeah. Yeah. And to solve it, if you can write SQL statement to solve it, then that's the best, right? SQL statement. In case it could happen, you may not be able to solve by SQL statement. Then you have the last way to do it. Yeah, let's assume, because that operator is too complicated. No matter how hard we try, we couldn't get it. Yeah. Let's assume that could happen. Yeah. Then you may need to write stored procedure. You write a program, write a function to do it. Then you can do it, right? Because in a function, in the program, you can write a lot of code, right? Definitely you can make it. It's very rare, but you just get the problem solved, right? Yeah. The last thing, because suppose some operator is very complicated. So no matter how hard you try, you couldn't get the exact result in certain DBMS, okay? Yeah. The last thing, let me write a stored procedure to do it, okay? Because in the stored procedure, you can write many commands, right? Not just one command, okay? So you can get the data, so remove those you don't need, only keep those you want, right? Yeah. So at the end, you get the same thing. Yeah. but you need to call a store procedure. Okay? Whenever you need to run the query, instead, you just call a store procedure. Okay? Yeah. So don't worry. Yeah. You can do everything. Yeah. So here, because in this class, we do not have a chance to practice that store procedure. I just give you the concept. Okay? I just describe, the capability you can do by the store procedure. Yeah. But if you get to the point you are in a place to use store procedure, you need to do further study by yourselves. Yeah. Store procedure. Yeah. All right. Yeah. So that's how much I want to cover for the complex queries. Okay? Yeah. So this is the end point for the complex queries. Yeah. So after this class, next class, we just do review. Okay? Review for the final. Yeah. So practice, I give you more examples, mainly query examples to practice. Okay? Preparing for the final. Yeah. All right. So that's it.